So think back, we are in the mid-80s. Not really high-performance computers in the mobile stations. So yes, we do have some security built in, but we do not really have extreme strong security in the devices. Because of computing power and also because of the idea behind security. What is the idea behind that? Well, basically, it was decided that it's not necessary to have more security than a normal ISDN network, for example. You could also tap the wires there. So this is why end-to-end encryption not really necessary. Okay. So, and another idea was, well, we trust the network, but maybe we do not trust the single users. So we have to protect the network from malicious users, malicious devices. And additionally, because now we have a mobile device, we want to have something like theft protection, at least a certain protection that no one can access personal user data. So that was one of the key ideas. Which security services does GSM offer? Quite important is access control. This is not the fixed phone at home, but a mobile phone. So who really accesses the device and who accesses then the network of a certain operator? So authentication of a user is important, but also authentication of a subscriber. Subscriber device, we will see the device itself is not that important. So first of all, what do we have? That is the authentication of the user against the subscriber identity module. This is where we use the PIN, the personal identification number, usually 4 digits. So that means that the subscriber identity module sees, okay, this is the right person. Well, the SIM only sees this is someone knowing the PIN. That's all. Without the PIN, you cannot use the subscriber identity module. This is why you get the PIN on a separate way from your operator. So you have a subscription, you get the SIM, the card, or the eSIM is already integrated, and then you get either a letter or whatever, you can access it via a web interface. You will get your PIN. If you enter a wrong PIN for several times or 3 times, then you need something that is called a PIN unlocking key, and then you can again unlock the SIM, re-enter a PIN, etc. If you type in a wrong PIN unlocking key several times, you will simply, prick the SIM, so you cannot use it anymore. So that's it. So that's the authentication of a user against the SIM. And then the second step is the SIM against the network. Why not the device? Well, GSM separates the SIM from the device, which is important. The SIM, the subscriber, is important for the network operator because the subscriber has a contract. The subscriber pays independent of the device. The device itself is not that important. So the contract, the subscriber, and the SIM brings this all together. So that means the SIM authenticates itself against the network. And this is where we use a certain challenge response method I will show you on the next slide. What else is important besides authentication? Confidentiality. So voice and signaling is encrypted on the wireless link, not in the fixed network. This is not end-to-end encryption. Why? Well, during system design, the decision was made, why should we make it more secure than, for example, the classical ISDN network? The wireless link is a problem because it's very easy to listen to the wireless link, compared to a wire, but you can also do it with a wire. And so the decision was made, okay, only encryption on the wireless link. What else is important? Anonymity. So we're dealing with phone numbers. They're important. The International Mobile Subscriber Identity. But this identifies usually a person. We don't like this. So we want to keep at least a certain anonymity inside the network. This is why GSM uses so-called temporary mobile subscriber identity, which is not the phone number, and the TMSI is changed from time to time. Each time, for example, you perform a new location update, then you will get a new temporary mobile subscriber identity transmitted in an encrypted fashion. So location update is performed, for example, if you leave a certain location area, that's the area certain visitor location register is responsible for, you enter a new area, then you perform a location update. Or the operator actually triggers the location update, well, once, 2 times a day. 3 algorithms have been specified in GSM. 2 only have an open interface, so the interface can be found in the standard, but the algorithm itself is kind of secret, or at least was secret. And then there's a standardized encryption algorithm. The names are A3 and A8 for the kind of secret algorithms and A5 for encryption. So A5 is standardized and open, and this is the algorithm implemented in the device, in the mobile station itself. So this has to be an open standard because the device manufacturers have to implement this. They are in the device. They have to be, well, powerful enough to do a, well, real-time encryption, decryption. And then we have A3 and A8, but they are located in the SIM. They are not in the device. And there, well, each provider could use whatever algorithm there, because only the algorithms in the SIM and in the counterpart, which is the authentication center in the network, they have to be the same. So you can easily change the algorithms A3 and A8 because they are on the SIM. So they were in the early days of GSM kind of secret, but you can actually download them from the internet. And this is also a reason why the network providers can use stronger mechanisms. Why those mechanisms are relatively weak, the original A3 and A8. So there are many stories around this. In the early days of GSM, you could actually clone SIMs. And one example was that rental car companies, they had built-in mobile phones in the cars. And so people rented the cars, cloned the SIM, and then misused the cloned SIM card, for example, during night when they assumed, okay, the car maybe is in parking garage, no one uses the built-in mobile phone because you cannot use the same phone twice in a mobile network. Network will detect this. So they used the cloned card because the algorithms were relatively weak. This is why some of the operators quite soon used new algorithms. Then there are other stories why using weak algorithms, because at that time it was not that easy to decrypt the encrypted messages if you used real strong algorithms, but different secret services wanted to listen into the communication. So this is why those algorithms were even artificially weakened after their introduction by, well, request from some services. Okay. But you can use any stronger algorithm for A3 and A8. How does it work? Well, authentication. That's needed when you initially, for example, access the network. So you need 2 parties. One is the authentication center. That's usually located somewhere on the premises of the network operator. Look back at the architecture picture, there you will find the authentication center. And you need your SIM, not the mobile station. What happens now? in the authentication center and in your SIM, there's a secret key, KI. This is the individual subscriber authentication key. You cannot read out this key from the SIM. This is not possible. So this key is located, stored on the SIM, and you will not find out what the key is. The key is also protected in the authentication center. For authentication, the authentication center sends a random number over the air to your SIM. Everyone can read the random number. Now, both sides, the authentication center and the SIM, use the algorithm A3, take the key KI and the random number, use the algorithm, and calculate a so-called signed response on both sides. So that's the idea. So this is our challenge, the random number. We calculate now the signed response, and that's then our response, and we send back the response over the air. Everyone can read this, and the MSc will then compare the signed response created by the authentication center and the signed response created by the SIM. If they are equal, the SIM is authenticated, not the device, not the user, but the SIM. The network provider is not interested in if the phone is stolen and someone else abuses your phone. As long as there's a valid SIM, someone pays for it. And that's the important part. Okay, so that's the authentication. And to find out the key, the secret key KI, it's quite difficult. So you could send many challenges, these are the random numbers, to your SIM, and then by looking at the signed responses, you could find out the key. But there are several mechanisms to protect the SIM. For example, the SIM can be quite slow in the calculation because you do this only for the authentication, so it takes some time, so you cannot send many random numbers. And then you could also simply integrate a simple overheating mechanism. So if you perform this too often, the chip will simply be destroyed, because usually you use this mechanism only once in a while. But if you try to do this 1,000 times per second, for example, the chip will simply overheat, and that's it. So you can protect chips in different ways. So that's used for the initial authentication. So you log onto the network. Then you participate in the mobile phone network, and then we use the other algorithms. We use A8 and A5. How is this done? Now let's assume you want to set up a call. Again, we use the authentication center and the secret key KI on both sides. Again, we send a random number to the SIM, and then together random number and secret key, we generate a cipher key, KC. The same is done in the authentication center, and then we send this cipher key to the base station subsystem, and inside the mobile phone, the SIM sends this key to the mobile station. You see the clear separation of SIM and mobile station. The SIM is integrated, well, yes, you put it into the mobile station, but it's a separated device, own operating system, memory, processor, etc. So now the base station subsystem, BTS, BSC, has the key, but also the MS. And now both sides use this symmetric scheme for encrypting and decrypting data using the algorithm A5. So this is a symmetric scheme. We use the same key on both sides. And over the air here, everything is encrypted. So now this is 64-bit key. Well, looking back from today, this is not strong anymore. And additionally, this key was artificially weakened by setting some bits to 0, which weakens the key, so that some services could actually listen into the conversation. So this is not end-to-end encryption. This is only a certain kind of encryption between the mobile station and the BSS. That's it. So So we will learn a bit more about systems that really have strong end-to-end encryption, not these systems. Sure, you can put on top of this your own encryption on the device in your application, but that's a different story. So that's the idea of the GSM standard when it comes to protecting, for example, a voice call over the air. Some questions. Looking at the security mechanisms, what is protected by these GSM mechanisms and what is not protected? So what is missing if you compare these mechanisms with maybe mechanisms you're used to have in today's communication systems? And what were the reasons for these decisions, well, many years ago while designing the GSM system?